If we put our new sweater in the wash, it shouldn't come out looking worn. If we bend over, our jeans shouldn't burst. And if a flame skims your skirt, it shouldn't end in tragedy. We hold our clothes to rigorous standards, and thanks to testing, they generally meet them. At the Fashion Institute of Technology, Professor Sean Cormier teaches textile quality assurance, which sounds starchy, but could be rather unorthodox.
What's your favorite part of your job?
Well, my favorite is burning, tearing, and ripping.
Using machines that function like medieval torture devices, Professor Cormier destroys and distresses sample fabrics until they yield the results his students require.
So we always have a certain kill ratio built into what we're doing. And the only way to understand if your product is going to perform is through testing.
The fun begins by scrutinizing your sample, determining the very fabric of the fabric.
We actually count the number of warp yarns and the number of filling yarns that are in that fabric per inch.
If your shirt is advertised as 150 thread count, somebody probably poked and prodded at it with tweezers just to make sure. Next, you break out some corrosive chemicals.
This particular fabric is made out of two different fibers, acetate and rayon.
Acetate provides that glossy pseudo-silk quality and is dissolved by, you guessed it, acetone.
If the sample was 10 grams and now it's 5 grams, we know that the sample is 50% acetate and 50% rayon.
This isn't just to make sure the seller gets the right fabrics from the manufacturer. It determines if you can put it in a dryer or if it's dry clean only. Next, Professor Cormier takes a sample and crocks it till it bleeds.
Crocking is color transfer. It's caused by excessive dyes on the surface of the fabric.
Different fabrics absorb different amounts of dye.
Well, suede, it's been rubbed and sanded, and some of that causes some of the dyes to come to the surface of the fabric, which leaves the extra color on the surface, which can easily come off.
So it's best to lay off the blue when making suede shoes. But crocking isn't the only measure of a fabric's dye. Pour some acid on it and see how resistant it is to sweat.
But my lady does not sweat, she perspires, okay? So we want to see how the acidic solution from the perspiration affects the colorant. Does it break any of the coloring bonds? Does that then tend to bleed off on other fabrics?
Or, on the other side of the pH spectrum, bleach it and see what sort of washing it can put up with. After these chemical tests, Professor Cormier turns to destruction of the physical variety.
Well, we love to break our fabrics, okay? So we have a machine, constant rate of extension machine, that pulls on the fabric until it rips.
Determining how strong the weave of fabric is seems straightforward. Seems being the operative word here.
Generally, you're looking for your seam to be about 60% as strong as the fabric. Of course, we want the seam to eventually break because it's easier to sew back up a seam than to reweave fabric.
After he tears the fabric, Professor Cormier simulates the dreaded pill.
Those little balls that are formed on the surface of the fabric by the swinging of the arms, the rubbing of the thighs. Well, synthetic fibers are man-made fibers, so those fibers are very long. And if one of those filaments breaks, okay, that will then curl up, causing a pill.
And then there's staple fibers.
Things like cotton, wool. If there wasn't enough twist put into that particular yarn, some of those fibers can get loose during washing or during wearing and curl up, entangle with other fibers, causing pilling.
Large fibers and yarns can also get snagged on a pocketbook or a belt buckle, anything with a sharp edge. How does one objectively test for that? With this thing.
Well, the snagging machine is generally for fabrics that have very loose stitching or fancy yarns.
And of course, for the final test, Professor Cormier breaks out the fireworks.
For 2 seconds, we impinge the flame on the surface of the fabric. And as that flame travels up the fabric, it then hits our piece of string, which burns and drops the weight down on the timer, stopping the test. So generally for most apparel, the fabric must take longer than 4 seconds to burn.
And if it fails this test, or any other test,
it has to stay at the factory. So if you want your goods to move, and you want the goods to get into the retailers, it will have to be tested.
And this is pretty much the case for all the clothing that you wear.
Every manufacturer in today's world does most of this testing on their product to some extent. I've looked at fabrics where I think they're going to fall apart, yet they're very strong. I look at fabrics that are very strong, and they're not. So it really is a fun, interesting thing because we get to break things, rip things, tear things, but ultimately it's for customer satisfaction.
For Science Friday, I'm Luke Groskin.